Hello, everyone. We continue with our discussions related to linear probability model. The videos are just maintained for 10 minutes. As I told in the previous lectures, in order to facilitate easiness for you to navigate through these topics, right? So the number of videos might be more, but the duration of each video will be maximum 10 minutes, not more than that. So here we are going a little deeper into understanding what is the linear probability model. So in the previous class, I had introduced to you what is a linear probability model. See, linear probability model is one of the easiest ways in which we can incorporate dummy dependent variables into a regression model, right? We have till now in the previous lecture, I have introduced the idea of dummy dependent variables, right? When your dependent variable is a dummy variable, right? How do you model such kind of a case? That's basically what we are trying to understand here. The easiest way in which you can do this is just incorporate the dummy dependent variable and run a typical Euler's regression, right? And that's basically what we call as the linear probability model. Now you may have questions or doubts as to why this is called as the linear probability model. There is an explanation for each of this, why it is called linear and why it is called as the probability model. I'll try to explain that with the help of this example. See here, as you can see, I have wrote down this econometric equation, right? Di is equal to beta 0 plus beta 1 Fi plus beta 2 Ri plus epsilon I, right? What does each of these stand for? Di stands for the model tried to estimate, right? It is trying to estimate the possibility of a state having a female governor. Okay, so the primary variable of inquiry or the dependent variable here is a dummy variable, isn't it? It is finding out whether the state will have a female governor or not. So there is no way in which you can quantify it. It is a qualitative variable. So that variable we capture as a dummy variable. And how do we define that dummy variable? We define it as di equal to 1 if the state has a female governor, and 0 if it is otherwise. Okay, if it doesn't have a female governor. That is the way in which we, because we have seen in the earlier classes also that dummy variables will take binary values, are usually assigned binary values, Q values, isn't it? And commonly it is 0 and 1 that is assigned. Okay, so in our case, the dummy variable is whether the state has a female governor or not, right? So in order to capture that, we are saying that di, if it is equal to 1, then the state has a female governor. We define it like that. And if it is 0, it means otherwise. That's basically the major way in which we define this dummy variable di. What are the independent variables here? You have variable fi being taken into consideration and ri being taken into consideration. What is fi? Fi is the percentage of females in the ith state's population, whichever state that you are taking. What is the percentage of females within the total population of the state? That's basically fi. Okay, and ri refers to the percentage of social conservatives in the population of that state. Not in the population, in the register among the registered voters. What do you mean by social conservatives? See, there would be, we are in a larger patriarchal system, so there would be a large number of people who wouldn't want a woman to assume a very high post of a governor, etc. Right? So people who maintain such kind of a mentality are what we call as social conservatives. Okay. Who has a very gendered view of who should be there in power positions, etc. That's basically what we have called them. We call them as social conservatives. So RI indicates the percentage of such kinds of social conservatives within the among the registered voters in that particular state. Okay, and the possible signs, right? We can hypothesize the signs of these two variables like this, that if the percentage of females within the population of the state is higher, it is likely to have a positive influence for the state to have a female governor, right? If it is, see here, what we are assuming is kind of a situation where the governor is an elected representative, right? It may not be the case in the Indian case, but let's consider uh, it this way for the sake of this example. So, if the higher the percentage of female population within the population of the state, you have a higher likelihood, right, for getting a female governor. If the percentage of social conservatives happens to be high, right, that is people who do not want a woman to assume such a high position of power. If their percentage in the population is likely to be high, what is likely to happen to the dummy variable? It is likely to exert a negative influence. So that is why we have written here that states with higher percentage of female within the population and lower percentage of social conservatives, they are the ones who are likely to have, right, a female government. Okay. So here, if you look at the right hand side of this equation, this side of the equation, okay, let me use a different color. If we just take into consideration the right hand side of this equation, you can see that all of these coefficients are linear in nature. You don't see any squared or cubed values, etc. They are all linear in nature, right? Uh, and that is essentially the reason why we call this as a linear probability model, because it is linear in the coefficients of the equation. Okay. The equation is linear in its coefficients. As you can very well see, it is seen here, beta 1, beta 2, etc. are all linear in the coefficients, and hence it is called as a linear probability model. Okay. You look at the left-hand side of this equation. Left-hand side of the equation has di, which is the dummy variable that captures the possibility of whether the state is having a female governor or not, which we have defined as d equal to 1 if the state has a female governor and 0 if it is otherwise. See, the question is, what does this di indicate? Right? What does this di capture? See, when you put this econometric equation, you run a Euler's regression, etc., and then you find an estimated value for this, right? Always and everywhere you get an estimated. Let's say that this di has an estimated value, as I have indicated here, right? It has an estimated value equal to 0.10. That's what you are getting. What does this 0.10 mean, right? See, at the end of the day, we have told that this is a dummy variable, isn't it? Which doesn't capture a quantitative variable, it captures a qualitative variable. So how do we make sense of the estimated value of di, this dummy variable, being equal to 0.10? See, this simply means 0.10 simply means that there is a 10% chance. Okay, there is a 10% chance that di will be equal to 1 as defined here. That's how we have defined, right? di will be equal to 1 if the state has a female governor. So this 0.10 indicates the chance of di being equal to 1, or it indicates the probability of di being equal to 1. Or in other words, it indicates the probability of the state, of the ith state, having a female governor. The probability of the ith state to have a female governor. That's basically what this di equal to 0.10 would indicate. It has a 10% chance there is a 10% chance for the ith state to have a female governor. That's the meaning of this. Okay. So here, as you can see, this estimated value, right, helps you understand the probability, isn't it? It helps you understand the probability of, it's an estimate of the probability that di is equal to 1. Okay. And hence the name linear probability model. Okay. Why is it called as linear? Because it is linear in coefficients. right? Coefficients of the equation are linear in nature. Why is it called as a linear probability model? Because the estimated values of di, right, which is the dummy dependent variable, would indicate the probability that di is equal to 1. In our case, what is the definition that we have given for di equal to 1? We told that if di is equal to 1, the state would have a female governor, right? So this value, as I have just indicated, for example, if the di estimated value is 0.10, right, that would mean that there is a 10% chance for di being equal to 1, right? Or in other words, there is a 10% chance for the ith state to have a female governor. Okay, I hope this is clear. So this is about the estimated value of di, right? Now talking about the coefficient, right? Coefficient of a linear probability model. How do we interpret the coefficient of a linear probability model? I think I'll do it in the next recording.